Sections 5.1 and 5.2 within Chapter 5 on factoring. Section 5.1 was focused on removing a common factor. So we need to understand, well, what is a common factor? When two or more numbers, variables, or algebraic expressions are multiplied, each of those being multiplied is called a factor. 5 times 3 has two factors, 5 and 3. 5x squared times 3y to the fourth power has two factors. When asked to factor a number or algebraic expression, you are being asked to determine what factors, when multiplied, will result in that number or expression. So if we were asked to factor 15x times y, we're asking what numbers multiplied together would equal 15xy. So we need to know what two numbers can I multiply together to equal 15. 15 is a multiple of 5, so 5 times 3, and x times y are the only two variables we could multiply together to equal xy. So the factors would be 5, 3, x, and y. If we were asked to factor 5x minus 15, we want to look at each term individually. 5x, compare that to 15. Ask yourself, what factor do they have in common? What is the greatest common factor? Both of these numbers are divisible by 5. 5 divided by 5 equals 1. 15 divided by 5 equals 3. If I divide both of those numbers by 5, I would be left with a 1 here and a 3 on the right. So this is 1x minus 3, which is what remains in our parentheses. And what did we divide by? We divided by our 5. We can double check that this multiplication problem would give us the same number that we started with by distributing that 5 into the parentheses and saying 5 times x minus 15, and yes, that does work. 12xy plus 6xz. Well, they both have an x. And looking at our numbers, 12 and 6 are both divisible by 6. So I can factor out or divide out a 6 and an x from both of these terms. If I do that, I pull out 6x. I'm left with 12 divided by 6 is 2, and 6 divided by 6 is 1. So I'm left with 1z. 12 divided by 6 was 2. We took out the x, we factored it out, and we are left with y. And that's what remains in the parentheses here. So we want to always go with the greatest common factor, and 6 is that greatest common factor between 12 and 6. So here are our steps for factoring a polynomial. Determine what is the greatest common factor. Then look at the variables. What is the greatest common variable amongst the terms? And once you find both of those, remove them and see what remains. What remains should be placed in parentheses. So here's an example. Factor 36a to the 6th power plus 45a to the 4th minus 18a squared. So what do they have in common? They all have the variable a. What's the highest power that they all have a listed to? A to the 2nd power is the largest power. They don't all have a 4 or a 6, but they all have a factor of a squared. Then let's look at the numbers. 36, 45, 18. Is there a factor that can divide into all three of these numbers? If so, what is the biggest number? So if you want to, you can start with 2. Are they all divisible by 2? No, 45 is odd. How about 3? Are they all divisible by 3? Is there a number bigger than 3? And we can work our way up to 4. 4 does not work. How about 5? 5 does not work. 6 does not work. Can't go into 45. 7 does not work. It's not a factor. 8 also does not work. How about 9? Yes, 9 works for all three numbers. 9 times 4 is 36. 9 times 5 is 45. And 9 times 2 is 18. And so that's where we end up with 4a, 5a, and minus 2. So let's determine where and how we get our exponents. Well, we took out a squared. So what we're doing is subtracting 2 from 6 to get 4. And the exponent 4 here minus an exponent of 2 gives us 2. We subtracted a squared from a squared in the third term, and so we're left with just the number 2 here. So we have factored, and our final answer would be 9a squared times the quantity, in parentheses, 4a to the fourth plus 5a squared minus 2. And we can check that these two are the same. You know, what we started with, what we factored, is actually equal here by distributing this number on the outside of our parentheses into every single term inside, just to make sure that we end up with the same expression that we started with. Here's just one more example here. We want to factor. Look at your numbers. 8, 16, and 24. They all have a common factor of 8. They are all divisible by 8. And if that's not a number that comes straight to your mind, you can ask yourself, are they all divisible by 2, 3, 4? Work your way up. 5, 6, 7. Check it on a calculator if you need to. And then ask yourself, what variables do they have that are the same? They all have an x. What's the highest power that they all have an x written to? I see a 2, 3, 3. So the highest power that they all have is a 2. How about a y? They all have a y. This one's y to the first, second, and second. So the largest number that they all have would be y to the first. So that's how we get our greatest common factor, 8x squared times y to the first power. Or we can write it as just y. We don't need that 1 there. And when we factor that out, we would be left with, if I take away 8 divided by 8 would be 1. When we are dividing by expressions here, we subtract exponents. Excuse me. So we would have 3 minus 2 would be x to the first power. 16 divided by 8 is 2. X squared divided by x squared would cancel. Y squared divided by y to the first would give us 1y. And then in the last term, we'd have 24 divided by 8, which would equal 3. X cubed divided by x squared, we would subtract 3 minus 2 to get this as a x to the first power. And y squared divided by y to the first, or y squared minus 2 minus 1, would also leave us with y to the first power. So we are simplified. We have factored as far as we can go with this expression. So within this one's a lot easier, right? Both numbers are the same, so the greatest common factor is that 9. They both have an a and a b, so we would just take out the number exponent that is the highest that they both have, a squared and b squared. This is one that looks just a little bit different. Whereas to factor, here we have a product on the left and we're subtracting another product that is on the right. So what would be our common factor? Well, both of these are being multiplied by 3x plus y. So that's our common factor. So if we take that out, what remains? We're left with 6, and we're left with a negative z. So if we combine those two together, that's where 6 minus z comes from, and we take our common factor that we were still multiplying by, and now we have two expressions that we're multiplying together, 3x plus y times 6 minus z. We can redistribute this out by using the FOIL method just to see if we would end up with the same result. And a last example here, factoring out, these both are being multiplied by 2x minus 3. This is times 1, 1 times 2x minus 3, even though 1's not written there. So what we'd be left with is 7x squared minus 1.